think we scared everybody off bringing up compliance at an Agile conference. But hopefully my slides will pop up here in a second. So I'm Matt. I flew over from Sydney. You can tell by my accent I'm not quite from around here, but relocated about a year and a half ago. And so here are my slides. And yeah, so that's me. As Nigel said, I've done a lot at Chef. I've been there for about 7 years, which is forever when it comes to startup time. And there's my email, and if you want to get a hold of me, and I got a podcast. So let's dive into it, right? We're talking about writing software. So most people probably have a continuous integration, continuous delivery pipeline that looks kind of like this. You've got your dev, your QA, staging, and production. You know, fairly straightforward stuff. And you know, I'm a developer. I was writing code, and this is what our infrastructure looked like. And then one day, compliance shows up, and the auditors come in and they say, "Hey, you guys, it's a nice pipeline you have going here. I like the fact that you're doing continuous integration. You've got testing. You're releasing 5 times a day. That's all very exciting, but we've got some audits we'd like to check on." And who's seen this before, right? You know, if you touch money or healthcare, you probably have something similar to this. And they've got a huge binder of paper, some PDFs, maybe some Excel, and you're like, all right, you're gonna roll up your sleeves, take a look at what we got. And the first thing on the docket is the SSH controls. And so you open up your big binder of paper, and you see that there are 2 versions of SSH, and you should not be using SSH v1 because it's been broken for a long time. And please use v2. And you're a good sysadmin. You think, well, how am I going to verify this? And so, of course, you're going to break out grep and sed because you're on Unix and you're old school. And so you're going to look for the protocols. You're like, okay, I got this. I can fix that. And so the next page says we're going to talk about how your Apache servers are secured. And so there's an item called Apache server information leakage. And this is when you go to a website and you drop off the web page, and it says, hey, we are serving up Apache 1.1 on Solaris 7.0. And you're like, hey, that's a lot of leakage of information. People know what your operating system is, what version of Apache is. You don't want to expose that. So we want to write a check for that. More sed and grep, because you know that's the kind of sysadmin I am. And so we check for the server tokens and look for this. Feeling pretty good. And then the next thing we get is the Center for Internet Security benchmark for CentOS 6. This is 172 pages long. That's a whole lot of Perl or awk or sed or grep, probably beyond your level of comfort for scripting. And so you're kind of banging your head at this wall. But you know, the auditors, they get paid to come back, right? So you want them to come back in 3 months, and they want to be back in 3 months. So eventually, you pass your audit, right? I lost my slide. There we go. So you pass the audit. You know, the auditors, they give you a passing grade of a C-. And you know, you've gone through the theater of the machines are all passing, and nobody changed anything while the auditors were there. And then as soon as they leave, you go back to what you were doing before, which is why you were failing when they got there. But you know, you go back to work. But your security officer says, no, not so fast. We're going to introduce a new step called security review, where anytime you go to release code, we're going to have a security team review those patches to make sure that this is all going to be safe to release into production. And so clearly this becomes a blocker, right? If you think you're going to release 5 times a day and you have some team who has to review all the code, if they ever go on holiday or you know they just can't keep up with the amount of change, all your continuous integration releases, they start to back up, right? And so the compliance team becomes this wall slowing you down. And that's not what we're about. We like to release quickly. So you go and you talk to them and you say, well, how about we do scanning after our applications and infrastructure have been released, right? That sounds safe. So essentially we're putting out our code into production and then scanning it after it's already out there and running and hopefully secure. but probably not. So this isn't the best of models. And the problem with compliance and security is it's not something you can bolt on after the fact. You can't say, hey, we spent 9 months developing our application, we got 2 weeks to secure it so we can go to production, right? That's not the right approach. You want to build compliance and auditing into your workflow. You want this to be part of how you operate, right? That's how well-behaved software pipelines are going to behave. And we've seen this, right? This is the Verizon's 2015 State of PCI Compliance Report. I'm sure 2016 is much, probably telling the same story. The nice thing is you didn't actually have to open the Word doc or the PDF, because right there on the cover it says 2/3 of organizations did not adequately test security of all in-scope systems. So, spoiler alert, don't even read it. Your infrastructure is probably not secure. And we've seen this, right? The trends are kind of inescapable. You're starting to manage more and more infrastructure, more and more applications. You're trying to release faster. But what we actually see from this PwC survey is people are releasing faster and scanning less. So probably not a surprise. We all probably have free credit checks through our credit card companies, or whoever has lost our information lately. And that's bad news, especially if you touch money or healthcare. And so, I talked about security theater. This is the fact that your auditors are actually incented to help you pass so they can come back and get paid again. And nobody really wants to spend the time to lock things down, because that's hard, right? So really, our goal is to pass those audits without going through this process of theater. And the results that we get back are a big binder of paper, which is how we kind of got into this mess in the first place. You get an audit report that says, hey, you passed. You passed in November, and then it sits there on a shelf. And then your auditors come back in January, and they point at the binder, and they're like, yeah, it's still there, and it's got a nice layer of dust on top of it, because nobody really looked at it in the meantime. Right? And if we look at these shell scripts, that's not super readable. I mean, unless you're a Unix or sysadmin, a Unix admin, this is probably not the most easiest to maintain. And if you are, a DevOps engineer, if you will, you're probably used to the idea of infrastructure as code. Maybe you're using Chef or some other tool, and you've got your own tools that configure your infrastructure as code. And your auditors, of course, are working with PDFs and spreadsheets. And so we have a communications problem. People are not using the same tooling, but they all have the same goals, right? And one of the things that when we start talking about DevOps and infrastructure as code is we don't want humans on machines. That's kind of an anti-pattern. I mean, I've said it before a few times that humans logging into computers is an anti-pattern. You should not actually have that. What your goal at the end of all this is when your auditors show up, you point at a bunch of servers and you say, no humans have ever been on these machines. Here is the code that set up these boxes, and go read that. If you don't like it, delete any of those machines and I can replace them from scratch, right? That is really the goal here. The clock is moving. And so, in the DevOps community, we're used to this idea of infrastructure as code operating on servers. And one of the things that we talk about at Chef is the fact that culture and tools are reinforcing. You can be the best DevOps engineer using Bash and Perl and hopefully CVS, but some tools work better than others. And some patterns reinforce the tools. And so you want to use the best tools for the job. And so one of the things we talk about is when we start talking about using code on servers, we want to have we want to have all the stakeholders using the same tools. And we want tools that reinforce the behaviors we would like to see. And so I'm going to talk a little bit about an open source project called InSpec. InSpec is based on the idea of compliance as code. So this is what InSpec looks like. It's a compliance language. It's a very high-level domain-specific language. We're going to describe the configuration file or the resource on the server, how we would like to see it. It uses the spec style of testing framework. So if you've seen RSpec or server spec or any of those style of testing tools, you've seen this high-level description of the results you want to see. I want to see the protocol should equal 2. That's something that your auditors can probably read. They can understand that. But we also have a lot of metadata here as well. We have a title and a long-form description, so you can generate reports off this. You can get nice output and format it however you like to see. And then we have an impact. Is this critical? Running an old version of SSH is probably critical, or is it trivial? You get a lot of those warnings. You want to kind of filter down on the sorts of stuff you see. So this is what the inspect language looks like. This is a compliance language, and it works on Linux, but it also works on Windows, right? Because obviously we're gonna want to secure our Windows infrastructure too. And so this is an example of looking at a Windows registry key. If you're a Windows admin, you've probably poked around in the registry before. And this may look like Greek, but this is what registry keys look like. And again, it's very high level. It should exist. We want to see this key for NTLM v2 authentication. This is how your Windows machines authenticate with Active Directory, right? You don't want your XP boxes joining your 2016 domains. And this is the sort of stuff you would have in a large compliance profile of all the little things you're going to check off for on Windows. And we want the value of this key to be equal to 4. Again, very high level, very readable. Inspec also works with Mac OS, Solaris, AIX, HPUX, BSDs, all the operating systems. And it has all the resources that you would kind of expect to see for a system administrator. Managing things like packages, services, which keys are on your registry, which Windows features are installed, all that fun stuff, which users exist. It's not intrusion detection, right? This is not a firewall. This is just looking at how your boxes were set up after they've been configured, right? So maybe they've been set up by hand. Maybe they've been set up in an automated fashion. This is not antivirus. This is not a zero-day exploit finder. This is really just the sorts of things that your auditors are looking for, right? Your auditors are not security experts. All they have is a list of things to look for to make sure that you're probably doing things the right way, hopefully. Lots of fingers crossed in that statement. It also works with bare metal, VMs, containers, cloud instances, databases. Databases are kind of interesting. So one of the things that Inspec can do is connect to your MySQL, Postgres, SQL Server, Oracle databases, and run queries against them. I mean, how many times have people shipped MySQL with the default user still installed? Maybe you don't know you're doing that. But if you're installing it from Ubuntu, you probably are. So this is the sort of thing you can query for users. You can check results. This is also a good way to do synthetic testing. If your machines have been set up properly and your databases have been configured, you could run a query just to see if the sorts of things you want to see exist inside your database. Inspec can also talk to APIs. And the nice thing about talking to APIs is you can start talking to cloud APIs. In this case, we're talking to security groups on Azure. So we can actually go and see that the security group should not have an inbound rule with the source of 0000/0, which means it's just open to the world. What this allows you to do is not only are we checking how your servers are configured, but we're starting to raise it up to the level of talking to that infrastructure layer. You're on AWS. You want to make sure your users have multi-factor authentication enabled. Right? That's something that maybe your auditor hasn't thought to look for that, but somebody probably on your security team, when you start talking about moving into the cloud, they're worried about those sorts of things. And so Inspec works beyond just servers, but actually could talk to AWS, Azure, vSphere, a couple of other APIs. And so Inspec works either locally. It's command line. You can say, inspec exec, I want to run a test locally. The tests are written in Ruby. The DSL is very high level, but if you needed to do something interesting, maybe talk to an API, calculate something dynamically, do something interesting, you do have the flexibility of Ruby. It also connects to machines remotely. And what this means is you can scan all those machines that you've already sent out there into production, and you don't know what they're running. You can write up your audits, scan a bunch of machines, and see if you're still PCI compliant like you thought you were when you set those boxes up. Connect remotely via SSH, via WinRM for Windows. If you have your Windows authentication, your passwords, works with SSH keys, whatever it is, also works with Docker. So as people are starting to move into containerized infrastructure, InSpec can talk to the Docker host and scan the running instances to see if they are actually set up the way you would expect. So it's completely agentless, and that's kind of important. Because you want to be able to find out what's going on in your infrastructure. Cloud platforms, I guess. And so InSpec is open source. InSpec is open source. It's Apache licensed. And so the Apache license is one of the more liberal open source licenses. It means you can do whatever you want with the code as long as you give attribution and don't try to enforce software patents against it. So InSpec actually has a very active open source community with a lot of contributors who don't work at Chef. We're starting to see this used by the likes of Accenture, Deloitte, PwC, because this takes away that grunt work of the audits that your junior, first day on the job auditor, you say, hey, go on site with this customer for 2 weeks and SSH into a bunch of boxes and see what's happening, right? That's kind of how things work. So there's a very active open source community. Contributions from Oracle, from HPE, from Microsoft, from IBM, making sure that their operating systems and applications are well covered. And Supermarket is the Chef open source community site for sharing things. There are about 60 existing profiles out there. So whenever there's a new zero-day exploit, for example, there's some new CVE that you have to worry about. A lot of times people publish, the way to detect it to the Supermarket. We also have a training site called learn.chef.io that has completely free training series on how to do InSpec. And of course, a Slack channel, because everybody loves Slack. And so this kind of goes back to a very simple pattern. This is not DevOps, really. This is just good system administrator hygiene, good operations hygiene. The first step is to just detect what's going on in your infrastructure. You write these compliance profiles, scan the machines that you have, find out what's going on. One of the things we've seen from the State of DevOps report is that 55% of organizations do compliance assessments inconsistently or not at all. People don't know what they're actually running. I mean, it's probably not a complete surprise given all the recent news, but this allows you to accurately assess your risk. This allows you to identify what the problems you have in production are. Then you can say, well, we need to correct those things. And so step 2 is correct. Let's detect what's going on, and then we'll go and correct those things. Maybe you do it by hand. Maybe use an automated tool like a Chef or System Center or Ansible or Puppet or whatever. But again, most organizations don't have the ability to remediate things quickly. And so one of the things we've seen is there's a new vulnerability like WannaCry, for example. WannaCry was a recent Windows vulnerability that Microsoft actually sent out a patch in March, and then WikiLeaks leaked out some CIA information about, hey, here's some things that they use to exploit Windows machines. And then, 2 weeks later, there was this vulnerability called WannaCry that started doing encrypting machines and then saying, you needed to send us some Bitcoin or you wouldn't get your machine back. And so, Microsoft quickly said, hey, we fixed this in March. It's May. Why are you not patched yet? And so about 6 hours after that, we released a WannaCry profile. It's really simple. Microsoft had a list of 20 knowledge base articles that said, if you have one of these hotfixes applied, you are not vulnerable. It's easy to check. But I'm working with a large Australian telco who, it took them 8 weeks to check the machines that they had. They had 1,500 Windows machines that they actually had to log into each of them manually, see which patches were installed, install the right patches, and then go to the next one. These machines were in production, so they had to do it after hours as overtime. And so as you can see, that's a fairly expensive proposition when we have another customer who they were in a POC with 2,500 machines when shell shock hit. Shell shock was a bash vulnerability. And so those 2,500 machines, they checked them in 15 minutes just to see if they were vulnerable. And then they rolled out a patch in about 45 minutes to upgrade the version of Bash across those 2,500 machines. Fortunately for this customer, they had another 60,000 that were not in the POC. And so those machines took 9 weeks to remediate. So again, basic system administrator hygiene. But once you have those remediation steps in place, you've identified what needs to be fixed. You've patched it by hand. Maybe you've automated it. You want to bring that back into your software development pipeline, right? This is when Agile meets infrastructure, you start talking about DevOps and automating these things. That's what you want to do. These scans that you're running out in production, those same inspect scans can become part of your software delivery pipeline. You can have your developers have to run through these checks, these automated checks before they push things into the next pipeline, just to see if they've done something like turn on telnet or finger or some deprecated protocol that is known to be vulnerable. And so if you bring this back into your pipeline, it's going to catch a lot of the things that your auditors are going to flag. And so ideally, once you've automated these things, it's not going to happen again. And so this is the journey to continuous compliance. It's not exactly DevOps, but it gets you on that path. Find the things that are wrong, remediate them, build that into your pipeline. Maybe instead of just fixing things that are broken, you start to build them right the first time. And so that is the journey, and that's one of the things that we help people do with the surety. But again, Inspect is completely open source. Chef Automate is our platform for helping people do this. Ships with a whole bunch of industry standard stuff. The one slide about commercial stuff, but it ships with like the CIS benchmarks and PCI compliance and that kind of fun stuff. But again, I talked about learn.chef.io. There are completely free training for Inspect. Inspect, again, completely open source. You can do it on Windows, you can do it on Linux, lots of open source compliance profiles. And so go check it out, and that's that.